Over the last year, I've created a lot of small demo projects, but I've never actually managed to get one game to the finish line. So I decided that this time I'm gonna set a strict deadline and try to finish a game in 2 weeks. And guess what? I actually managed to do it. Is the game perfect? Absolutely not. Obviously, it's missing some of the nice to have features that I wanted to add in the game, but it actually has all the core features that I envisioned the game would have. And that's actually the important part. Is the game actually doing what I wanted it to do? Yeah, it does. And some downsides are the UI can use some improvements, the gameplay can be more deep, more refined. But again, I'm actually happy with the result, and the game is actually multiplayer and it works in multiplayer, so that's a win. You can do like PvP with your friends, and that's actually kind of fun, even though it's not like, you know, CS level PvP, it's still some kind of PvP. And what I've learned is that setting a strict deadline is a great way to get things done. Why did I say that setting a deadline is a great way to finish a project? Well, imagine that I didn't set a deadline and I was like, okay, let's just start working on a game, and maybe at some point I'm like, okay, I implement some features, I finish the multiplayer, but now I go into a rabbit hole and I'm like, maybe let's add some particle effects, maybe let's add some song in the UI and let's improve the UI, but those things are not really that relevant to the actual gameplay, so why even bother adding them in the first place? Like, first I would focus more on getting the gameplay done, getting the core features, so um, you know, being able to actually spawn the player in the scene, even if you don't have a UI, even if you don't have a main menu, just being able to spawn the player, let the player move around, it actually makes even developing the game more fun because you are able to playtest while you are developing. So for me it was something like, okay, let's add the player in the game, and I was like, oh shit, it's actually funny to move around the character controller in the scene. And then I was like, okay, what else would a tank game need? Like, obviously being able to shoot the tank, like that's the so that was, the next thing that I had to add. And then obviously being able to deal damage, because initially you can shoot a projectile but there is no damage systems, so that's also another important thing that you have to add. And then again, on top of that, you need to be able to respawn. And sure, like, respawning is not really necessary, you can just crash the game, and I know I did that before in like a game in the past where we implemented our own programming language and managed to do like a extremely simple game in that one, and if you died, it just crashed the game. It's like, you can do that, but it's more convenient to let the player respawn. So even if that's not like 100% needed, it's still better to add it. And sure, at some point you need some UI, because if it's a multiplayer game, you need a way to connect to a server, and I didn't want to just hard code the URL of the server. I wanted to, let the user paste in the URL. And that was another funny thing. Copy paste doesn't work in text boxes in the game engine that I used. For some reason, you have to type it in, which is pretty funny. But again, it's not something that I would say it's extremely important to have. Like, copy pasting, who cares? You just type in an IP. So that's also something I would have probably gotten into a rabbit hole if I didn't have a deadline. So again, it's a good thing that we had a deadline. And you might wonder, what if I didn't finish the game in 2 weeks? Well, I would have called the project a failure, scaled back the features, and tried again. Like, make the game smaller and try again until And I repeat this process until I can say, okay, this is what I can achieve in 2 weeks. And of course, like, unexpected things can happen, but what's important is understanding the difference between being 10% done after 2 weeks and being 80% done. And I would say that, if you are only 10% done after 2 weeks and your deadline was 2 weeks, it's like, maybe the game is way too complex, or you don't even need to think about it as a, like, for a game. Maybe it's like, I don't know, web server or something, like a different project. But if you look at your features that you wanted to add and you only managed to finish 1 out of 10, it's like, yeah, maybe it was a bit too complex for only 2 weeks. You can either give yourself more time, or maybe make a simpler project. Depends on how much time you want to invest in it. So, and also another aspect of the deadline, if you think back on the uni days, or if you're still in uni and you have homeworks and projects, especially in computer science, that's always the case. You know that you're always more productive in the last 3 days than you are in the entire, like, 3 weeks of, um, since the homework is announced. But I mean, I was the kind of guy that sometimes did the homeworks in the first few days, but only for the subjects that I really liked, because they were fun. And I guess that's another thing that you have to take into account. If you think the project is fun, or at least you're excited about it, the first few weeks are gonna be easier to work on it, because you're gonna be not necessarily obsessed with the project, but you are gonna enjoy it more than other kinds of projects. So if you give yourself like 2 weeks or 3 weeks, um, you're gonna be like, okay, it's pretty cool. I want to finish it, right? And I mean, usually for me, like, a project like this, after 2 or 3 weeks, it starts to become more of a chore. So yeah, I guess 2 weeks for me is a good deadline for a small project. But yeah, like, we'll see if we can do some other bigger stuff. Maybe more time would be needed. So we have to see. But yeah, again, like, if you enjoy something, for me at least, the sweet spot is around 2 or 3 weeks until it becomes annoying. Maybe it depends also on how much time you spend on it, but yeah, like, so I'd say it's pretty important to set a deadline. At least, even if you have like stages, like, in the first stage I want to have just the multiplayer implementation, because that's the hardest part. And if I have the multiplayer implementation, then I've escaped the multiplayer, so now I can focus on something that's more fun. And then for stage 2, you can say, okay, now I'll focus 1 week on adding the player and some mechanics. Or in a web server, you can say, okay, I finished the authentication, which was the most annoying part. Now I can focus a bit on some backend, and then in the last part I can focus a bit on UI, or on creating some HTML pages that look nice. And yeah, that can also work. But yeah, what's important is to not go too deep into rabbit holes, right? Not waste that much time on things that are not important. So if you think to yourself, okay, in 3 weeks I have to finish it, I have to ship it, then much, much better. Now let's talk about the elephant in the room. What game engine did I use? If you've been following my channel, you know I'm a big fan of C. And initially I wanted to write my own game engine in C, but what I quickly realized was that doing so would make finishing in 2 weeks impossible. At the same time, I didn't really want to use Unity or Unreal Engine, because, well, I mean, they're kind of too mainstream for my taste. And yeah, I am like that. So I went for the next best thing, which is Rust. But Alex, you can't use Rust for game development. Well, I just did. And my entire channel is about proving that you can build anything in whatever language you want. And the main reason why I chose Rust was because of the Bevy game engine. If Bevy had been written in Python, I mean, I would have used Python. It's just like that. And I mean, honestly, Rust kind of sucks, but I really like the idea of the Bevy game engine. And Bevy is an ECS, which means Entity Component System game engine. And it's basically data driven. I don't know, it's just what Wikipedia says. I don't know what that means. Honestly, it feels kind of similar to Unity in a weird way. Like if you think about it, in Unity, when you create a game object, you add some scripts on it, which are usually called components. And I see the same component thing in the ECS. So I'm like, huh, is it the same thing? And it kind of is, if you'd ask me. Like, I'll be honest, it kind of is, because when you create an entity, you add some components on top of it, just like you do in Unity. So that feels like it's the same thing. But what is the difference? Well, in Unity, the components actually have some logic inside of them. So they have some update script or update function where you run some logic. But in ECS, you don't have any logic on the component itself. The component is just data. So you can think of a component as the settings that you set in Unity's editor, right? You set like the velocity, the acceleration, stuff like that on your components, and then inside of the update function you use them. But in Bevy, what you have to do is you have a separate function that searches for your components. It makes some queries. You can write your own queries, and then it uses those components to like modify them basically. So again, it is kind of similar, but it kind of separates the components from the update function. And I think that's uh, pretty cool, because you don't have, you know how in Unity you have to depend, one component depends on another component, and you set these dependencies in the editor, and sometimes they break and it's really annoying. Well, I mean, in Bevy it's not like that, because you don't need to set them in an editor, you just set them in code and they remain uh, set. They cannot break. It is what it is. And yeah, basically I think it's way cooler like this, being able to have a function and you say in that function that, okay, let's search for all the objects, or here it's entities that have um, let's imagine an object. Let's say it has a transform component that we want to change, and it also has a velocity component that contains the velocity. And you can see how here you can actually have arrows, players, cars. Like, it doesn't matter what they are. They can be like anything, as long as they are updating the same way. And that sounds kind of interesting. You don't have to create how do you call them in Unity? Because it's been a long time since I used Unity. I think it was prefabs. Yeah, you don't have to create prefabs. I mean, you could, but what's the point? So yeah, that's kind of the point of Bevy. You don't have both the logic and the data in the same component. You have the data separated from the logic. The data is in the component and the logic in the system, and that's kind of fun. And this makes the code more modular. It's easier to write, and you can easily test individual systems. So you can, and I should have used this feature more. I usually write examples in which I use certain components and certain systems. I just use them in an example. And for instance, you can test, like, let's say you test a bullet, how it flies in the air, and you can test it individually. That's pretty cool. I mean, you can do the same in Unity. Obviously, you create a scene an example scene where you test something. That's same idea. But that makes it easier to test individual things. And my only problem with ECS is over engineering. And I guess you can easily get lost in the architecture and forget to actually make implementation of the gameplay. And I think that the best way to learn is by making mistakes. And this is one of the mistakes you can make, over engineering. You'll be like, oh, I wasted some time on over engineering something that I'm not even gonna use, or I guess reuse, because that's usually the main reason why you over engineering. While you over engineer, you are like, oh, I'm gonna reuse this thing in another system. It's like, let's implement because Rust also has this problem, right? You are like, oh, let's implement a trait for something. Why? And with ECS is basically, if you think about it, it's both ECS and Rust, which are over engineerable. I don't know if that's over engineeringable. That's a trait which I just invented because I'm a Rust user. So yeah, exactly. It's really easy to over engineer in ECS and Rust. So that's a big issue. You have to refrain from doing that. But yeah, again, if you make that mistake a few times, you'll be like, okay, let's not do that again. And what usually works for me is to just have a single file in which I put everything, and I slowly factor out things as I see fit. And it's like, okay, now it makes sense to just take this thing and move it into a utils file. And there's no really magic formula here. You just have to use trial and error until you actually get the hang of it. And like watching tutorials or stuff like that, I'm not really a big fan of doing stuff like this. If you've been following my channel, you know I'm a big fan of practicing over watching tutorials. And I think tutorials or courses about how to structure projects or how to over engineer stuff, it's useless. I mean, you'll be better off just by trying to implement something rather than trying to learn from someone else. Now, this might sound like I'm dissing my own content, but I I mean, I'm actually doing it honestly. You'd be better off by just trying to implement your own stuff. And sure, like you can watch tutorials about certain things, but I think, especially when you use something like, let's say, Blender for the first time, and I'm like, okay, how do I do X in Blender? And I find a video of 2 minutes and like, okay, perfect, that's exactly what I needed, right? Like that's, those tutorials are good, but I wouldn't waste that much time on courses. Maybe just skim through them and try to figure out what the project is about and then implement it yourself. And then after you implement it, maybe you can go back to the course and be like, okay, let's see if I implement it the same way, or if it's something that I missed, or did I do something wrong? Or at the end you'd be like, okay, the project works exactly like as I expected, but it's different. Is it wrong? Well, if it works, it's not wrong, you know what I mean. So yeah, I'd say that's my opinion on tutorials and why you shouldn't waste that much time on courses. As you might have guessed, the game is multiplayer, so obviously networking is a big focus. And luckily for me, I already implemented a few multiplayer demos, so I had some experience with it. But for a complete beginner, implementing a multiplayer game feels completely different than a single player one. And that's mainly because when you do a single player game, you'll put all your code. Let's say you start out just like me with a single file and you put all your code in a single file, and you expect it to be like, okay, this is my single player game, I handle the inputs, I update the player position and so on. But instead of having to do that, when you create a single app, now it's different for each kind of game, but for the server client style game, which I like more than other, like hosting, like becoming both the server and the client, like hosting a game, instead of having a single app that runs both getting the input and updating the game state, you have to split it into two separate apps, the server and the client. And the client just handles the input of the player, so it takes in the input from your keyboard and let's say it saves it, right? But you cannot see the player moving at that point. It just reads your input. And what you have to do from the client is to send this input to the server. So you say, okay, player one actually clicked on W, so we have to move it forward. And that way the server is the only one responsible of actually updating the game logic. Because if you think about it, if each client updates the game logic, then who do you trust? Like, which one is the source of truth for the other clients? Because if someone has bad internet, then maybe their or maybe has a bad computer, maybe their state will be different than another players. So it's gonna be like, oh, why did I die? Because I was behind the corner, stuff like that. And the other thing is people cheating. Like you can easily cheat if you become like the source of truth for the multiplayer game. You're like, okay, player 3 died, but how did they die? I don't know. They just exploded for some reason. That's what the code said. And yeah, that's why you want to have a server authoritative approach. Sure, there can be more complicated stuff, but I decided that for this game in particular, I'll just go with you send the input to the server computes the new game state, and it broadcasts to all the clients the game state. Oh, sounds quite simple, but figuring this stuff out took me like a really long time. And I can really understand here the point of view of someone who's a beginner. Probably doesn't make any sense at all initially, but if you gain some experience with implementing web servers and the UI, maybe that makes more sense. But it has to be that kind of server side rendering stuff. That's a better way of doing it with web apps to get more experience in this game dev multiplayer world. Okay, so anyway, right, as I said, there are multiple architectures, but this one, server authoritative, is the best one, or I guess the easiest one, I would say. Maybe the easiest one is actually uh, the one that allows cheaters to exist, which is the client does the logic and it just sends the updates. But it's if it works, I guess. But the server one is better. Okay, so yeah, sure, you can go even more complicated. Like maybe you notice that sometimes in some games you get like rubber banded and moved around a bit sometimes because the server thinks you're at some position and the client thinks you're at another position. Because why does that happen? Because you do client-side predictions. I didn't go into this topic because it was way too complicated, and I thought that okay, for 2 weeks it's gonna be a bit too difficult. But if I noticed that I have more time left at the end, and the performance, I wasn't happy with the performance. It looked like the client was not really that responsive. Like the tank was moving really weird. I might have tried to do it, but didn't really notice anything that wrong with it, other than a few bugs. But that's, game development in a nutshell. But yeah, so I didn't require that. So why go into it if I didn't need it? And that's another important thing. If you are not sure if you need something, then probably you don't need it. So, I mean, that's the best way I can put it. So, sure, you should do your code like expecting changes, but honestly, if you don't have the time, then why bother? Because you're probably not gonna change it. Like in my experience, I'll be honest, uh, I think I never actually needed the change that I was thinking about needing it. So, but I don't have like 20 years of experience. But uh, if I'm being honest, I never actually changed something. Uh, and it's the same as with Git. When I'm saying, okay, I'm using Git because I want to be able to go back in history and revert changes. I think maybe I reverted once or twice, but usually I just use Git to version my code and like to save the code in a state. So that's whoops. But yeah, it's the same thing here. If you think, oh, I'm gonna need this stuff and that stuff, I'm gonna over engineer my code just to accommodate for it. I mean, it's not worth it. You're probably not gonna need it. So yeah, I guess that's just my point here. I could have tried to implement client-side prediction and reconciliation from the beginning, but I was like, okay, let's see how the game works without it. And surprisingly enough, it was fine. I mean, I know for FPS games, you kind of need it because it's every millisecond matters, but um, I mean, it's good enough. If it's good enough, it's good enough. Or what can I say? And now another thing is that Bevy, the game engine, actually made it surprisingly easy to take the single player demo and turn it into a multiplayer game. And that's mainly because of the ECS architecture. And it was also because, as I said, I had some experience and I already implemented the systems in the way that they were already separated from the beginning. So you can imagine I had a system that read the input and then it stored that input into some variables, and then I had another system that reads from those variables and updates the client, like the tank's position. So what I had to do was to copy the system that reads the input into the client app, and the system that updates the position into the server app, and then just link these two systems with messages. And I think because of the library that I used, I was able to just use events. And on top of that, the library also had some, you don't even need to write any code for it. It just syncs the values over the network. And yeah, and for who's interested in, the code and what stuff I used Renet and Bevy Replicon for the networking. And yeah, I'd say that these were really easy to use. And I'm pretty sure Renet works. You don't even need to use Bevy. You can just use it as a standalone thing and do a game from scratch. But yeah, they were pretty nice to use and actually made synchronizing stuff extremely easy. And I was also able, actually I used Renet 2. For some reason Renet 1 doesn't have wasm support, so I used the second crate. I don't know, Rust people. So yeah, basically that one adds wasm support, so I could run the game in the browser. But I would recommend these crates if you are working in a bevy multiplayer game, because extremely easy to use, much easier than other options that I tried, and I mean, they work. So that's the important part. They work and they're easy to use. Now, I'm not gonna say that Bevy is the perfect game engine, and it has quite a few issues, and I want to address some of the issues that I found while working with it. I guess the biggest issue that I found was that on each release, a lot of features are gonna break. And that's mainly because Bevy is still under like a lot of development, and from one version to the other, a lot of changes are gonna happen with the API itself. And that means that if you want to update your code base to use, let's say you go from bevy 0.14 to bevy 0.15, well, that's gonna break a lot of stuff because, as I said, the API is gonna change and you have to make, I mean, it's not gonna be that bad. You have to fix some things, and the documentation is really good on like there is a section about how to migrate from one version to the other, so it's quite I mean, it's not that hard of a process as you might think. But where this really sucks, let's say, is if your game depends on a lot of external libraries and you want to update Bevy to the next version, you have to make sure that all the other libraries are gonna support the new version. If, let's say, only one of them is not gonna support the new version, then I mean, tough luck, you cannot really update it. Or what you have to do instead is, I mean, you have a few options. You can either not use that dependency anymore and implement it yourself, or you can make a PR and update the library yourself or something like that. And I guess this could be a big, let's say, turnoff for some people that want to get into Bevy. But I'd say that, it's um, kind of similar with Unity. If when you open up Unity Hub, it shows you the version that you have for Unity. And if you try to update to a newer version, again, the project might break and you have to do some fixes. And I would say it's much harder to do that with Unity because if something in like how the materials work or how shaders and uh, objects like game objects themselves work, it's gonna be harder to fix because it's not only code, it's also like, let's imagine animations break, right? You have to fix the animations by redoing them, and it's gonna take much more time than just fixing code, which is what usually happens with Bevy. So that's I say at least that's one upside with Bevy. You don't have to worry about uh, you know PNG is gonna remain a PNG. So if you have assets that are PNGs, they are not gonna break. And I guess the other inconvenience is that Bevy doesn't have a built-in level editor. And you might be like, if you come from the Unity space, you'd be like, whoa, what? And I know it sounds weird, but you actually do everything from the actual text editor. So you implement everything like by code. You don't really have, I mean, you have assets, you can have images, obviously, but you don't really drag and drop images around the scene, right? And I know that kind of sucks if you want to implement a game that uses anything else than procedural generation for your world. But I mean, you can still use Blender to create scenes and then load them into Bevy. It's a bit complicated to do that because you have to, um, because Blender, when you export an object and you load it into Bevy, I'm not sure why it doesn't keep the proper names for like the names that you put inside of Blender to objects. It generates some names like mesh 0, mesh 1, or I don't know why. It's kind of weird. Maybe I don't use Blender properly and um, the names that I set the objects are not being properly set for some reason. I don't know. It's just probably it's just a thing with Blender, honestly, but yeah, it is what it is. And um, a really nice crate that I found is called bevy, and this one lets you export the components from the bevy game. So imagine components that are gonna look like the scripts from Unity, and then you can add those into Blender. So what you can do is to actually add components on the Blender objects that you create in a scene. So it literally turns Blender into a level editor for bevy, which is kind of cool. And at the time of doing this video, I was using bevy 0.15, and the problem was that bevy was only working with 0.14, and that sucks because this thing can happen quite often, that you use, bevy, like a certain version of bevy, and you find a cool library that cannot really be used because it's not updated to the latest version. And the solution is to either downgrade, but that sucks because you have to rewrite the old code into to follow the new downgraded version, or to wait for the library to be updated. Well, that's actually what a noob would do. A real Chad would make a PR to the library and update it himself. Luckily for me, I didn't have to let my inner Chad out this time, because someone else already made a PR and I just pointed my dependencies to the Git repo of that library. Something that I usually learn the hard way is that you should keep the project structure simple. Usually I overcomplicate stuff and start to refactor things way too early, in my opinion. And I think I try to do that here as well, but I'd say it was justified because of how weird it was to manage the wasm part alongside with the server code and the client code. And in a multiplayer game, what I would recommend to start out with is having a shared library for your networking protocol. So for the messages and some shared components that are going to be on both the client and on the server. And then you will need to have a client library and a server library. And what's important is that these two libraries, the client and the server, they shouldn't share anything between each, or like they shouldn't have any dependencies between each other. Any dependency that's inside of them should be on the shared library, and both of them are going to use this shared library for the stuff like player takes damage, or like that's a message, or the player pressed on the key W, or the transform has been updated from position X to position Y, or something like that. I think that's the best structure you can start out with, and then you refactor things out as it starts to make more sense. And as I said, something that I really struggled with was getting the wasm part to work. Some crates don't compile to wasm, for example Tokyo, or other stuff that depends on like, let's say stdlib, or like or how do you say it in C? It's like stdio, or I mean stdlib.h, right? Everything that depends on the clib doesn't work on wasm. So I had to use a lot of features and conditional compilation to make the game work somehow, and it felt a bit annoying to have to do that, but maybe just by practicing more I will find a better way of doing it. Another question that I was asking myself is how to structure the bevy related code. There are a lot of debates on the internet about how to structure your game code, and some people say that you should split the code into behavioral plugins, so like player, or like even better would be like car plugin, which is for cars, or sword plugin, which is for sword, stuff like that. And some other people say you should split it into system and components. And personally, I think I found that a mix of the both would make more sense, and I would have a tank plugin that would contain all the system and components related to the tank, like movement, renderer, audio, etc. And then I would have an audio plugin where I register the tank's audio or anything that contains audio, right? I would register it there. And then I would just have to register this audio plugin into the main file, basically. And this way I can just copy paste the tank plugin into another game and it would work. In conclusion, I'm happy with the result. I've learned a lot about game design, networking, and the bevy game engine. I've also learned that setting a deadline is a great way to get things done. I hope you enjoyed this video. If you did, please like and subscribe. And if you have any questions, feel free to ask them in the comments. Thanks for watching, and as always, we'll see in the next one. So, see you.